Earlier I have finished effect of compressibility. So, theory has been given by Basic 1973. Why this effect of compressibility has come into picture? Because there are two criteria, one is your local shear failure as well as general shear failure as per your Terzaghi's. So, instead of taking empirical things, so Basic has given effect of compressibility, one example I have solved. Then Bureau of Indian Standard codal provision, what is your bearing capacity? Bureau of Indian Standard provided separate shape, depth and inclination factor. They have also given water table corrections, Bureau of Indian Standard. Then bearing capacity of soil based on your standard penetration values. There are charts, Peck, Hansen and Turnbull 1974 has given proposed bearing capacity of soil based on SPTN value. From SPTN value you can get the value of phi. Once you get the value of phi, then bearing capacity factor NC, NQ and N gamma we can get it directly. Up to this I have covered, and Teng 1962, Teng 1962, he has given some empirical equation for ultimate bearing capacity of footings on granular soil. Footings on granular soil, Teng has given 1962. So, continuous or strip footings footing QNU is equal to 1 by 6 3 n square B RW prime plus 5 into 100 plus n square df RW. Square and circular footings, QNU is equal to 1/3 n square B gamma W prime plus 3 into 100 plus n square df gamma W. So, particularly if you look at here, this gamma W prime, gamma W, this is your water table correction factors, and n is your average n value. This is your average n value after correction. So, basically Teng has given this bearing capacity equation based on your SPT n value, some empirical for continuous as well as strip footing and square and circular footing. For example, suppose this is my n for number of penetration per blows and this is your depth, and this kind of SPT n value you are getting after taking into consideration of overburden corrections, after taking into consideration of overburden corrections. This is after your overburden corrections. Then once you plot the n versus depth, from this n you have to find it out what should be your average value. Once you get average value, then from there you can find it out what is your value of your net ultimate bearing capacity, because QNU is your net ultimate bearing capacity. B is equal to depth of footing in meter if dF by B is greater than B. If dF by B is greater than B, then use dF is equal to B. Then bearing capacity of granular soil from static cone resistance. Bearing capacity of granular soil from static cone test. There are two tests I have covered earlier in your geotechnical measurement and explorations. One is your standard penetration test, other is your static cone test or cone penetration test. So, this has been given by Schematman 1975. So, they have given a chart this is B in centimeter, width of footing in centimeter, then here it will be QNU by QC, QC. So, it is varying from 0 to 0.25 and width they have taken 0 to 400 centimeter. So, it will be 100, 200, 300 like this it will continue. Then so dF by B is equal to 1 in this case, then in this case 0.5, in this case 0. So, what will happen? Whatever the width is there, from there if you are taking, he has given a chart, from the width you take it, and for different depth to width of the footing this chart has been given. Suppose dF by B is equal to 0.5 and width B is equal to 200. From here you take it, what is the value you are getting? From here this value you find it out. This will give in terms of QNU by QC. QC is your nothing but is your cone resistance. So, you know the QC from your static cone test, whatever you are getting the value, suppose you are getting 0.25, then net ultimate bearing capacity is equal to 0.25 into QC, you are getting this value. So, directly you are getting bearing capacity from SPT, standard penetration test, and from also static cone test you can get it. Now, next part is if you come back to bearing capacity of footing on layered soil. bearing capacity of footing on layered soils. So, particularly on layered soil, you can always, in case of layered soil, you can always find it out what is the value of your C average as well as phi average. C average is equal to C1 H1 plus C2 H2 plus Cn Hn divided by height. Suppose take this example, there is a footing supposed to be constructed below a depth of say 1 meter, and this is your 2 meter, and these are all layered soil. It has been provided C1, phi 1, gamma 1, C2, phi 2, gamma 2, like this. So, in this case, depending upon that, either you calculate individually, because what will happen in layered soil, you have to find it out. Suppose this is a 2 meter, 2 times 2, 4 times of B, this is your influence zone, it will be 2B to 4B. So, 2B to 4B means, 2B means you are taking 2 into 2, so it will be a 4 meter, it will be 4 meter. So, in that case, in 4 meter, what are the value we are getting? C1 phi 1 gamma 1, C2 phi 2 gamma 2, C3 phi 3 gamma 3, C4 phi 4, C4 phi 4 gamma 4. Instead of calculating one by one, you can take one CU average considering these 1, 2, 3, 4 layers, and also you can find it out phi average, it will be tan inverse H1 tan phi 1 plus H2 tan phi 2, like this you continue, and total height you are considering. This is a general philosophy, but there are different conditions, there are different theories also for layered soils. This is out of scope. Generally in advanced geotechnical engineering or advanced foundation design, foundation engineering, in that case particularly master's levels, this in details in layered soil, how do you calculate bearing capacity, that will be discussed. So, if case 1, if the thickness of top layer is not sufficient to fully contain the rupture zone, so depth of rupture zone from the base, first find it out, depth of rupture zone from base. So, once you find it out, case 1, if the thickness is not sufficient to fully contain the rupture zone, so ultimate bearing capacity generally you consider shear strength of lower layer. So, there are 2 layers here and here. So, this thickness of upper layer, suppose this is your H1, this is your H2, suppose thickness of upper layer is not sufficient to take your rupture zone, then in that case ultimate bearing capacity you can consider taking into shear strength of lower layer, H2 layer, case 1. Case 2, if lower layer is a weaker layer, check whether the loading intensity transferred to the top of the weaker layer. If the lower layer is a weaker layer, check whether the loading intensity transferred to the top of the weaker layer or not by means of 2:1 distributions. So, this is there are many conditions are there. We will solve also problem while doing design of foundation, because every time you will encounter layered soils, it is not going to be a kind of single soil layer, either cohesionless or maybe cohesive soils. It is a layered soils. So, it will be, it is consisting of C phi, C1, phi 1, gamma 1, these are there. So, more discussion I feel will continue about your layered soil while designing the foundation, particularly after these settlement calculations. I will discuss more about this. So, now come to one example, simple example. A loading test was conducted with a loading test was conducted with a 300 mm square plate. That means it is a plate load test at a depth 1 meter below the ground surface in a purely clay soil. Water table is located at a depth of, I can put this symbol like this, water table is located at a depth of 4 meter below the ground level. Failure occurred at a load of, means plate load test failure load is given, that is your 45 kilonewton. This is what is about your plate load test. The question is, what is the shape bearing capacity of a shape bearing capacity of a 1.5 meter wide strip footing at 1.5 meter depth in the same soil. Assume gamma is equal to 18 kilonewton per meter cube. It is above your water table and a factor of safety 2.5. So, there is a ground here, in this ground it is proposed to be a footing, strip footing, constructed a strip footing of 1.5 meter wide, this is your B, and depth of the foundation also given, this is also 1.5 meter. This is what supposed to be proposed. when supposed to be constructed. Before constructing, it has been advised to go for a plate load test, and in that plate load test, how it has been carried out, the plate load test, it has been carried out below 1 meter depth, below 1 meter depth the plate load test. Plate size is 300 mm and it is a square plate and it is a clay soil. Water table is located at a depth 4 meter below your ground surface. So, from plate load test, the failure load is observed to be 45 kilonewton. This is what is your problem. So, finding out this shape bearing capacity, what is the formula? Terjag is CNC plus gamma DF NQ plus 0.5 gamma B N gamma. Basically, you need to have NC, NQ and N gamma. Let us solve this problem. So, what will happen? The plate size is 300 mm. If I take it 4 times, 4 into 300, that is your 1.2 plus 1, 1.2 below this plus 1, 2.2. So, water table is located at 4 meter below your ground surface. That means water table is at far below your ground surface. Similarly, if I am taking a footing 1.5 2B to 4B, it is also considered there is no effect of your water table. So, 1.5 into 2, 3 meter, 1.5, 4, 4.5, that would be fine. So, effect of water table on plate load test is negligible. So, it does not affect. So, from plate load test, Q ultimate is equal to failure load divided by area of plate, which is equal to 45 by 0.3 into 0.3, which is equal to 500 kilonewton per meter square. So, gamma is given 18 kilonewton per meter cube. This is, remember, this is a cohesive soil, there is no phi. So, that means phi is equal to 0. For phi is equal to 0, earlier I have given the chart, Terjag is bearing capacity factors charts NC, NQ and N gamma varying from phi is equal to 0 to phi is equal to 50 degree. For phi is equal to 0 degree, NC is equal to 5.7, NQ is equal to 1, N gamma is equal to 0. This value I have taken from Terjagi bearing capacity factors. Or from his charts. So, then Q ultimate, if I calculate, this is a square footing, this is not a strip footing. For square footing, Terjag has given 1.3 CNC plus gamma DF NQ plus 0.5 gamma B, it will be 0.4, not 0.5 gamma B N gamma. Then because N gamma is 0, this term will be 0, then it will be 1.3 CNC plus gamma DF NQ. Now, from there it is coming out to be 1.3 into C is equal to 5.7, sorry 5.7, C I do not know, NC is equal to 5.7, C is equal to C, gamma DF, gamma is 18 into depth of this particular plate load test, this is for plate, this is for plate, depth of this plate load test is your 1 meter. So, this is coming out to be 7.4 C plus 18. Now ultimate load of the plate we are getting from failure load by area, this is your 500 kilonewton per meter square. Now if I put it 500 kilonewton per meter square is equal to 7.4 C plus 18, from there I can get C is equal to 65 kilonewton per meter square. So basically C parameter has to be calculated from the plate load test once ultimate bearing capacity or failure load is given. Now for strip footing, it has been asked for strip footing. It is a strip footing, it is no more square. So here ultimate bearing capacity is strip footing CNC gamma df nq plus 0.5 gamma b n gamma, and this is your 0, which is equal to CNC plus gamma df nq, and net ultimate bearing capacity Q net ultimate bearing capacity CNC plus gamma df nq minus gamma df. So Q net safe is equal to Q net ultimate bearing capacity divided by factor of safety 2.5. So this comes out to be 148 kilonewton per meter square, because you know the C you are getting from plate load test, NC value is your 5.7 for phi is equal to 0, NQ value is your 1, DF is given 1.5, gamma is value is given. So this comes out to be 148 kilonewton per meter square. So Q safe, it is not net safe, Q safe is equal to Q net safe plus gamma df, which is equal to 175 kilonewton per meter square. So basically from plate load test we are getting the value of the C, taking the C value also from plate load test phi is equal to 0, from there we can calculate NC, NQ and N gamma, taking the value of the C obtained from plate load test and putting it for strip footing, we can get it safe bearing capacity of your strip footing. We will solve many more problems as the class progress. I will stop it here. Thank you.